Okay, this is the P4 paper from October 2020. This is question number 2, which we can see is a binomial expansion question. Let's have a look at it and see what we've got. We've got the function there, 4 minus 5x to the minus half, and we need to go up to terms in x squared. So let's make a start on doing that. Part A, we have 4 minus 5x to the power of minus a half, and what I need to do, I'm going to be using the formula 1 plus x all to the power of n, which we use for negatives and for fractional indices. That's going to be 1 plus nx plus n minus 1 x squared over 2 factorial, plus and so on. But actually we only need to go that far when we're doing it, but the key with this is that we've got a 1 there, and at the moment we have a 4 here. So not unusual stuff. You should have seen loads of these already. What I'm going to need to do is to take 4 to the minus a half out as a factor. If I do that, I end up with 1. I end up with 5x over 4 there to the minus a half. This should not be unusual. You should have seen lots of these before. Let's focus on this bit there. You can do it on the calculator, 4 to the minus a half. 4 to the minus a half is 1 over 4 to the half, which is 1 over the square root of 4. 1 over 2. So you can either stick it into the calculator or just know that that's going to calculate out to be equal to that. So now I'm looking at expanding that using this idea here. 1 minus 5x over 4 all to the power of a minus a half. Now what I'm going to do is actually do my answer, my full answer. So I'm going to go here and say this is equal to, and then I'm going to have my half outside the bracket, and now I can focus on just tidying up this bit using this one here. So it's 1 plus nx. That's 1 plus n is minus a half. And x, the thing that I'm adding on, is minus 5x over 4. So 1 plus nx looks like that. Plus n minus 1 is going to be minus a half. And taking 1 away from minus a half, you shouldn't have any problem, I'm just going to move this over, shouldn't have any problem doing something like that. You should have done lots of these in your practice of these. So n minus 1, x squared is minus 5x over 4 all squared, all over 2 factorial. Now I've got more than enough working out there now, so I would expect to just be able to calculate these whichever way you find the most efficient way of doing these. Some people try and work out what the sign is going to be by saying a negative times a negative is a positive, and then the same here, we've got negative, negative, and 2 negatives there, so 4 negatives will make a positive. So some people do it like that. Other people literally just stick into the calculator minus a half times minus 5 over 4, and then with the next one minus a half minus 3 over 2. Be careful here, minus 5 over 4 all squared, and then divided by 2 factorial, divided by 2. Whichever way round you do it, we should get the answer 75x squared over 128 plus ... but we only wanted up to the term in x squared. So that's going to work out to be a half plus 5x over 16 plus 75x squared all over 256. So that's the answer to part A. Part A said, can I go up to include the terms in x squared? I've done that. What does part B say then? Well, it's all to do with this function here. And what we notice about this function here is that I've got that part there. That is 4 minus 5x to the minus a half, isn't it? If it's divided by the square root, that's actually the same as this thing here. So what I've really got is 2 plus kx multiplied by that thing. So that's where I'm going to go when I'm going to start this. When we look at the answer, it tells me a partial part to the expansion, and so what I'll be able to do is expand it out using my work, and then I'll be able to look at the first term, the second term, and the third term, and see if I can, well, I should be able to work out what k is and what m is from those. Okay, let's actually do it. A little bit simpler when we actually go ahead and do this then. So for part B, I've got that fx is equal to 2 plus kx all over the square root of 4 minus 5x, but this 4 minus 5x, as I just said, that's actually 4 minus 5x to the power of minus a half. And because it's that, we can say that's my previous answer. That's 2 plus kx times a half plus whatever we had from before, 5x over 16, I think it was. And was it 75x squared? All over 256. Keep an eye on your handwriting as we're going through and doing this. So I need to multiply that all out. When I multiply it out, I'm going to do 2 times that one, 2 times that one, 2 times that one. That's fine. Get 3 terms from that. When I do the kx, I'll do kx times that and kx times that one. I don't need to do the last one because kx times 75x squared is going to give me a term in x cubed, which I don't actually need. So if I do multiply this out then, say 2 multiplied by all of those 3 is going to give me 1, 5x over 8, and 75x squared over 128 this time. And the 2 multiplied by the other ones is going to give me, sorry, the kx multiplied by the other ones is going to give me kx over 2 and 5kx squared all over 16. So what I now need to do is to look at the, look at the x's and tidy those up, and look at the x squareds and tidy those up. So this is actually 1 plus, well, for the x's, 5 over 8 plus k over 2, lots of x, and for the x squareds, 75 over 128 plus 5k over 16 x squared. Now, if we go back and look at what they said over here that that's going to be the same as 1 plus 3/10 x plus m x squared. So if I do that, what I can now do is I can equate the coefficients and just say that's the same as 1 plus 3/10 x plus m x squared. So from that, that's going to give me k, and then that should give me m once I've worked out k. Let's do the first part. So just make it clear to the examiner what I'm doing. Equating coefficient, sorry, handwriting, goodness sake. Equating the coefficient of x, I get that 5 over 8 plus k over 2 is the same as 3/10. So if that's true, then k over 2 is equal to 3/10 minus 5 over 8. That works out to be minus 13 over 40, which means that k works out to be minus 13 over 20. Not a very nice answer, I must admit. I'd be a bit worried if I got that as my answer, but I have checked it is correct. And then part C, finding the value of m. In order to find the value of m, again, if we look here, we can now use these 2 bits, remembering that we know what k is as well. So equating the coefficient of x squared this time, I can say that m is equal to, and it's 75 over 128, and then 5/16 of k, which is minus 13 over 20. That works out to be 75. Oh, you don't need all this working out now. Just making sure that I don't make a mistake here. But it works out to be that, which then works out to be 49 over 128. So the only criticism I've got really is the fact that both of those 2 answers look a bit scary, and I would have hoped they'd made it a little bit easier to then check to see that I've not made a mistake, because there's loads of places where you can make mistakes on binomials, but those are the correct answers. I've checked them with the mark scheme. So hopefully that will make sense to you.